السلام عليكم زملائنا. سلسلة انجينير توك مستمرة إن شاء الله، ولقاءنا اليوم مع المهندس فيزا ميتينين، التكنيكال مانجر لشركة بيكو في الإمارات العربية والمملكة العربية السعودية. محاضرة اليوم راح تكون عن دلتا بيم، هي الستراكشر سوليوشن، وعن أرماتا شير ستاد ريل للبانش سلاب. Dear colleague, today our series of engineers talk continue with Mr. Fiza Metinen from Biko Technical. From Biko, he's a technical manager in United Arab Emirates and Saudi Arabia Kingdom. Today's the seminar will be Delta Beam Structural Solution, Armata Shear Stud Rail Solution for Bunching Flat Slab System. Welcome, Mr. Fiza, and the board with you.
Thank you, Hakim, for the introduction, and welcome for everyone for the webinar. Let me share my screen. Tell me when you can see it.
Yes, it's clear.
Okay, let's start the presentation. So, like you said, the agenda today is Delta Beam composite beams, which we'll go through first, some basics, and then I will show you the design tools, what we are offering. And then we'll go for this Armata stud rails after that. Couple of slides for the beginning about the company. It's a more than 50 years old company, and it's a global company, started from Europe and now spread all over the world basically. And closest units in Middle East are factory in UAE, Ras Al Khaimah, and sales office in Aramat, Saudi Arabia. We have 4 different product segments. First is precast connections. This we are not going through today, but if you're interested later on, you can contact us on that. Then we have cast in situ connections, which is stud rails is part of the cast in situ connections. Then we have delta beam and delta beam frame, which are the composite structures and composite frames, and wind energy applications, which we will not touch today. But same thing like with precast, if you need more information, you can always contact us. So let's start with the delta beam composite beam. I will show you one video first. I hope you can hear the sound. Let me know if the sound is not clear. But let's try.
Mr. Fiza, can you check the sound? Because there is no sound, huh? No voice.
Yeah, that's what I was afraid. Sometimes this sound in the video is not coming through. I don't know what is the reason here. But yeah, and let's run it through without sound. I will explain meanwhile.
No problem. Proceed.
So, like you can see here, it's a slim floor beam, which I will explain more in detail after the video. So it can give you the option to lower your building height or lower the total volume of the building. The slim floor option. The cost effective. And, as it's a steel beam, the connections are very flexible to all kinds of columns. And all types of architecturally demanding shapes are easy to do. And MEP installation, because there's no drop. We will go through this, what you are seeing now on the screen, this delta beam select tool. After the slides. I will show you what we are offering for the designers, and I will briefly we are doing the inside in-house design here. And so far we have done more than 15,000 projects already. Sorry for the missing sound, but let's continue. So this is the basic section you can see here. So it's a steel section which is always designed project by project, and all these plates are designed specifically for the specific beams, and also the rebars inside the beams. And there is one feature is this web holes what you can see on the side, and this has important role to connect beam to the slabs, creating this shear connection between beam and slabs. It's like it was mentioned or shown in the video, it allows you to have a low floor height. So optimize your floor height means that you can also optimize the volume of the building. Perhaps even build another floor on top of the high-rise building or multiple stories. You can maybe achieve the same building height with more floors. And of course, it's sustainable because you can reduce your cooling costs in this area. There is no heating here, but cooling. And of course, also reduces your maintenance cost when your building volume is
Mr. Fiza, sorry for interrupted, but there is some comment from our friends. The voice, it's not clear if you can raise your voice or you can use mic or headphone, it will be better.
I will try to speak a bit louder. Can you hear me now better?
Please.
Okay. And like I mentioned, we are manufacturing this in Ras Al Khaimah for the Middle East market. So it's a local manufacturing sorry, I lost a bit of the touch.
No problem.
Very local manufacturing with very affordable prices and fast delivery times. So we don't need to import it from Europe or elsewhere. You saw in the video this MEP. So because it's a flat slab system, there is no drop. In most cases, we will design it without a drop, unless there is some very long spans and it requires drop. The floor option is not possible. And fire protection in the beam is built in, so basically even the bottom plate is exposed. You don't need to have any fireproofing under the beam. In the bottom flanks. And it's a light structure as well. If you compare to the equivalent stiffness of a concrete beam, it's much lighter. So it can allow you to optimize the foundations as well as the drains on the side. Here you can see as a comparison those typical steel and concrete beams, which are normally having a drop, and thus some of these benefits cannot be achieved with those systems. I mentioned it's a steel beam, which is we are manufacturing the steel part on our factory, and then we'll bring it on the site, and it will be filled with concrete, so it becomes a composite section in the end. And it's a very flexible beam in a sense of connections, so we can create a lot of different type of connections basically based on the project requirements. Can be pin connections, can be fixed connections. Slab types can vary from hollow slabs, which is the most commonly used slab type with this beam. And we have this kind of filigrane type of slab, half cast slab. Or can be steel decking as well. All kinds of slab types are possible. In the bottom section, you can see also beam connections, primary and secondary beam connections are possible, as well as cantilever in the beam. Then for designers, we're offering software components for the softwares you can see on the left side. So on the most used softwares, we are having the components readily available, and you can download it from our website. Then few words about the design. So as we are engineers here, most of us, so I will go through briefly the design principles we are following with this beam. So we need to have a three-stage design because it's 3 stages for the beam. First of all, erection stage is only a steel member because there is no concrete filling inside the beam yet. So we can only utilize the steel section of the beam. This is during the erection of the slabs, when you erect the slabs on top of the beam. Next phase, when you have erected the slabs, you will fill the beam and fill out the joints of the slabs if it's a hollow core slab. And then it comes a composite beam. And then we can utilize the composite section, including the concrete. We can utilize the top concrete structural topping as well. If in this area we always have the structural topping for the diaphragm for seismic, but in Europe there are cases where you don't have structural topping, you just have a levering scale. And then fire stage, like I mentioned, there is no need for any fireproofing on the bottom flange. But we are placing these rebars inside the beam to take care of the fire situation and the bending of the fire, because you will lose the strength of the bottom plate during fire. And that's why we have these rebars inside the beam, inside concrete, which is cooler. Calculations, I will show you next what kind of delta beam select tool we are offering for customers. But final design we are always doing in-house in Peikko. So I will show you after the delta beam select tool. I will show you briefly our internal software what we are using for design. Just for the same beam what we will calculate with this tool in delta beam select. I will go through the same beam design in our software. So you can find this software on this web page. It doesn't require any installation. It's a web-based tool. No need to have even registration if you don't want to print out reports. If you just want to see the section sizes. So I will go through this to our web page. So this is the front page. What you will see when you enter our website peikko.ai. Here you will click for designers, and here you can find delta beam select. And when you click it, it opens here, and you can click here, start using. And then it brings you to this website. So you can immediately start using the beam design here by clicking start design. Choose your location, whether you are in UAE or Saudi Arabia, you can choose it freely from here. Then what type of the building it is. I will choose now domestic residential building. And then it will bring you to this model here. So first of all, we need to put our beam here. So we can put, let's say, 6 meter long beam. Infill concrete, fire resistances are here. Slabs on both sides or one-sided, you can choose this as you wish. Then next one from the left side, you choose the slabs. What is it hollow core slab? 270 here. Top concrete, let's put 60 milli top concrete here. Maybe 8 meter long. Oops, sorry. And this tool is limiting the beam length to 12 meters for because this is typically the limitation for the transportation. So if you have longer than 12 meter beams, then contact us, and we will guide you on the special cases. because we can do more than 12 meters, but this is only the limitation on the software here. Then you have specified the slabs. Last thing to do is the loads. So you can see here self-weight is automatically taken care of. Temporary loading during the installation, all the people who are erecting, for example, on top of the slabs, it's taken care automatically, as well as the self-weight of the beam. What you need to do is put permanent loads, SDL here, let's say 3 kilograms per square meter, and variable load, let's put 3 as well. Now, if everything is set, you can then click calculate the case here on the bottom right. Then it will analyze the beam, that what types of, it will give you 3 different options if it's possible to use three different types, and we will see then what kind of options we have for the beam design. Let's see when the results will be available. It takes, depending on your network connection, it takes a little while. Looks like now it takes longer than normal. Okay, now we have got the results. So here, clicking go to results, it will show you these 3 options. So first option is slim floor option, which D26 means the beam height above the bottom flange. So it's the same height as the hollow core, 260. And 400 means the width of the web plates in the bottom of the section. Then we have another option with wider beam, 26,500, and then we have a small drop here, which is D30,300. So these are the options, and here you can see the approximate utilization for the section in ultimate states and service limit states. And this euro here marks just the ratio in the prices. So this wider beam is the most expensive, and related to that, these other beams are approximately 75 to 80% out of that price. So let's take this slim option, the narrower slim option. And if you have signed in yourself, you can create a report. So basically, this tool doesn't allow you to design those plate thicknesses. This is the detailed design which we are doing always in house in Peikko. So you will see the section width and section height, what is possible for your case. And then if you print this design report, you will see the moments, what are the moments according to the loads and spans what you have implemented there. So this kind of report will come available from the software. Then I will show you briefly our in-house tool. It looks like this. I made the same setup here. So our beam length is 6 meters, and from the middle of the beam to the end of the slab is 8 meters on both sides. And when we calculate the beam here, we can see the same what I mentioned on the slides. We have stage 1, then we have the composite states, and then we have fire states, and of course we have also the deflection service limit state here as well. So here we have the same section, D26-400, and I have used 20 milli plates and web plate 6 milli, and fire rebars 5 D32 inside the beam. This value here is a pre-camper value, so we are doing pre-campering for the beam for the erection state. So when you go to SLS, after you load this beam member with those hollow core slabs and at the topping, then we are designing this pre-camper so that the beam should be flat after this, and the final deflection comes to the composite member. So here we can see this. I will not go so much into the details, but moment for the erection states and moment capacity is here for different. If you want to see the values somewhere in the mid span, you can always track it around here. Same for the composite member. So here we have moment 551 approximately, and then capacity is 686. And when you are building, if you, let's say, if you want to do project with delta beams, we of course give you the details of the section stiffnesses, let's say, if you want to input it in your ETAPS model. So here you can see the steel section stiffness and then the composite section stiffnesses for sacking and hogging, depending if you have simply supported beams or continuous beams. And yeah, this is the deflection after pre-camber when you have erected in the slabs on the top of the beam and cast it. And this is the final deflection in the beam in the long-term final deflection, 5.1 millimeters. Okay, let's continue. This is briefly about the softwares. Let's continue for this Armata stud rails. I also no. Okay, let's go. Sorry, let's go through a few references for the delta beams. This was a hospital project in Riyadh. You can see here we created continuous beam lines, so it goes continuously over the column, and we can add holes in our beams, which allows the starter bars from the below column to go through the beam to the next column. Then we have Centria Mall in Riyadh with long cantilevers here. Longest cantilevers in the project were approximately 6 meters. So it was quite unique. And we have Sharjah Waterfront City, where you can see also this secondary and primary beam connection here. In the end of the cantilever, we connected the secondary beams to the primary beams. And if what comes to the long spans, you have here one project in Ras Al Khaimah where we had 18.5 meter span in the mosque project. So here in this part, you will have this dome of the mosque in the middle. Architectural expression here, you can see these curved sections created with delta beams. So here, actually, the beam section is straight, but we can do the formwork so that the facade surface will come curved already in the factory. And high-rise buildings. This is from Canada, just to show the high-rise buildings. These are also deep cantilever tips here in this building. Slim floor, saving the volume of the building. All right. Next topic was the Armata stud rails. Again, I have video. I'm afraid that the sound will not come, but let me try to explain. So this is also slim floor system, but for cast in situ structures. Of course, there's multiple options to how to deal with the bunching shear failure. So it can be column capitals or drop panels or thicker slab. You know, and the stud rails are the best option. And it's not only for the floor slabs, you can use it as well in the foundations. Similar benefits like with delta beam, of course, you can reduce the building volume, or you can reduce the floor to top height and build another. There can be installations on both creating these stud rails from the bottom first and building around it, or you can drop it from the top after you have done the reinforcing of the the structure. Oh, here is the same thing. You can see the different options with where you can use the shear studs. So this is our shear stud type. We have double-headed studs and only tack welded to the rails to keep the spacing and to provide the full rails already to the side. So we are not full welding. There is no structural welding between the flat bar and the headed studs because the anchoring will happen in the heads. This was in the video already explained, and similar benefit like with delta beam. We can reduce the floor height, avoid these drop panels, and don't complicate any of the installations. But just to have ceiling floor easy also for the partition layout. You can modify it later on if it's required. Capacity wise, you have also maximum resistance for the two-way slab. It's bigger or higher when you are using you can see the factor is approximately 30% higher than with the normal stirrups if you use normal stirrups. And this is because of the anchoring in the concrete. So there is no slip in the concrete when you use headed anchors, but it develops the full strength of the steel. Unlike the stirrup, which will slip inside the concrete and you will not reach the full strength of the bar. These are the failure modes. I will not go through. I'm sure most of you are aware that failure modes what can happen with punching in the slabs. Of course, the failure mode A you need to take into account. We cannot influence this with studs or any shear reinforcement, but this you need to take into account for the slab bending for it, enough negative moment reinforcement there. Basic design, of course, you will check the basic perimeter first. If the capacity is not sufficient, you will increase your perimeter by adding studs. You will check again, and if it's still not enough, you will add more studs. As long as your shear area and shear stress in the slab is able to carry the loads without shear reinforcement in the slab, and then your design is sufficient. And if you use our software, which I will show you after this, I will explain you the details how you use it, and then you will get a stud rail code, Armata in this case, and you can then specify it in your calculations and in your designs. Just an example how much you are saving. If you have no punching shear reinforcement, your slab thickness requires to be, in this example, 520. If you use stirrups, you can reduce it to 450. If you use stud rails, you can reduce it even further to 300. And of course, now this sustainability is a big topic depending on the project. So some projects already requires that you need to have LEED certification or other types of certification, because this will save you a lot of concrete. If 1 cubic of concrete is approximately 300 kilos of CO2. This will be good on the LEED certification to save the materials. Here you can see a screenshot from our software. So it also allows the openings close to the column area, which is difficult with drop panels to be achieved. And it includes ACI code and Seismic Design as well. Installation, like I mentioned earlier, it's very easy. You can do it bottom up. Like here, you can build the reinforcement around the stud rails, or other way around, which is the most commonly used, where you build your reinforcement and then drop these studs on top of the main top bars. There is no need for. That's why the quality checking is easy, because there is no need to check these studs because compared to shear links, you need to bend it always around the main bar and make sure that it is in contact with the main bar. But here we don't have this problem, so more freedom on the placing it on the side, and as well more security on the design wise. All kinds of concrete slabs can be used with post tension slabs. It can be used with the normal reinforced concrete slabs. All kinds of cast in situ slabs are possible, and foundations as well. It's approved system, and it's as it is specified in ACI, for example, doesn't require any specific approvals in most countries. We have local support here in UAE and Saudi, so we are close to you. We can help you with your projects and the design tools are available. That was it about the presentation. Let me still show you about the software. So if you go in the same place where we found this Delta Beam Select, you can also find this Spec Designer here. It's a free software. It comes with these modules. So if you click here and you input your email, you will receive the password for the usage, and you can start using it. It's free. So when you open the software, it looks like this when you open it the first time. So we have column connection modules. Then we have this punching shear reinforcement, embedded anchor plates with headed anchors. And these are web-based tools, Delta Beam Select and API Select, which is a balcony connector. So here we will try now this punching shear reinforcement design. All right. So if you choose ACI like we have chosen here now, it default is the imperial unit. So I will choose it to SI, which is more commonly used in the area here. So we want to have the metric units in use. Then we start specifying the slab, concrete in the slab. Let's say we have 35 megapascals concrete. Here column type, whether it's square or rectangular or circular. I can choose rectangular, and this is the position, whether it's in the middle of the slab or it's in the edge of the slab or in the corner. So you can click these values here. Let me choose the middle. Then your slab thickness here, as well as the column dimensions. Let's say we have 300 by 1000. Top and bottom cover here, whatever is your cover for the main bars. Slab openings. This is interesting, though. You can add either rectangular openings or circular openings, and you can add multiple openings, not just one. Here you can see either you can specify the coordinates here, or you can just drag and drop the hole wherever you want, and it takes it into account in the design. We have seismic design for higher seismic criteria. If you have seismic which you need to take it into account, you can click it here, and if you need to do the exact calculation, you can. I'm sorry, cannot see the edge of the screen here. Yeah, there you go. Seismic design. So if you have all the exact data, you can even optimize the seismic design. So if you uncheck this exact calculation, it is always conservative because it's for the maximum loads. Then your axial load here. Let's say we have 1100 kilonewtons and moments in both directions. You can use as per the design. Notice that this is the moment this is the unbalanced moment between the floors, what you need to input here. If you have post tension slab as per ACI, you can utilize also the post tensioning value, but this is as per ACI only utilized when your concrete grade is lower. I think it's approximately 30 or higher, then it has no impact for the design. But in case your concrete strength is weaker and you have post-tension slab, you can utilize this one here. And then the main bars, what you have. This will not have impact for the negative. It will not check the negative moment of the slab, but it has impact for the effective height for the structure. So put here your bars if you are whatever bars you are using, and then it will take it into account for the effective height calculation. And when it's green, you will see that the design is passed with this criteria. Here we have the code. It's unfortunately in inches because this Armata system was designed originally for US market, and it is in inches. So the code will come in inches, but don't worry, you can with our technical manual you can find the explanations for all these values. What are the values meaning for? So here you can have the explanations. The first number is the number of the Armata stud rails. Then we have diameter in inches. Then we have height of the stud in inches. Then we have number of the studs in one rail and the spacing of the studs. So there you go. And then when you choose the case over, it's jumping on the other screen, but here you can also export the AutoCAD for the same model. So if you want to export the AutoCAD design, you can do it from here, DWG, and it will create you the CAD drawing automatically. That was more or less what I had to show you today. If now we could maybe start with the questions, if any.
Okay, thank you. Thank you very much, Mr. Fiza, for this good presentation or very nice presentation. Actually, there is many friends, they couldn't be attend this seminar, but they send us a lot of questions in this regard. First of all, I will ask you, and this is actually what I face it as a problem with delta beam. Sorry for this. The problem, I found that I explained it to Mr. Muhammad, and I need your opinion in this. Actually, when you are constructing building, the client, he need one engineering person to do his engineering work, the design. But once we see this delta beam, they are not caring about the other design. They will say, Wallahi, we will design our element, and the precast they have to design, and the column or the frame, you will go to third consultant to do the design. So actually, this is a problem the client will face it. Especially maybe with the low-rise building, 1 floor, 2 floor building, it doesn't matter. But when we will go to high-rise building and we will make the design according to the wind load or earthquake load, here we will face big problem in coordination between these three parties. What is your opinion on this?
No, we are, of course, we are supporting consultants and contractors as well, that if you have the ETABS model already for the project, we will modify the ETABS model, use our stiffness values. What I showed you, we can export the stiffness values from our software, give it, or we can input it already in this ETABS model, or we can give it to the consultant who can do it for the ETABS model. So I think, of course, naturally the stability of the building is under a consultant, but we are supporting with our knowledge and giving values for the consultant to be able to put it.
Okay.
So in that sense, yeah, it's we are giving our support, and maybe it's something similar to the precast, like you said.
Actually, you will give the support, agree, but the problem now, the responsibility of the design will be, we will miss it actually. We need actually one consultant to do all design, so he will be responsible for his design. Right? If something fails, for example, if we face failure in the building, column or beam, for example, and this is if the beam fail, consequently, it will affect on the column and the slab, who will admit by his mistake?
Of course, we are the responsible party for the design and manufacturing of the beams. So if
for delta beam only.
Yes. But if we provide also the composite columns, then we are taking the full frame responsibility for the design.
Okay, thank you. The question is for delta beam system. Is there any code depend on Euro code or British or ACI or?
Yeah, most design in the software what I showed, it's mostly European design. If ACI design is required, then we are doing it manually. So the software at the moment we are doing, of course, all the time updates for the softwares, and ACI code will be added later on. But at this point, it is manual calculation.
Very nice. Type. There is one question said, what is the useful or function of circle openings for delta beam? This is, I think, economic side.
Yeah, this web holes, what I mentioned.
The circular holes in the delta beam. I think economic side.
We are calling it web holes because it's in the web plates. So this function of those are, let me take the presentation so we can see that. Function of those is actually here, you can see this.
Yes.
So this will create a shear capacity between the slabs and the beam. So this has a big impact. Of course, we don't want to put all the stress from the slabs to the bottom flange, but bottom flange will carry, of course, the slabs during the erection stage. Later on, when you do the infill concrete, it will create this shear connection, shear keys, you can say, between the slab and the beam.
Okay, very nice.
And this is the idea for that.
Another question said, when I have to use this is composite delta beam, fill it with concrete, we call it composite delta beam. So when I have to use it?
When do you have to use? If you want to use with precast slabs?
No, my question, maybe you didn't get me. My question is, this is a delta beam, it is hollow steel section.
Yes.
But you said during the lectures or seminar, we can use it also as composite and fill it with concrete. When we fill it with concrete, so the methodology of design will be different, right?
Correct.
So when I have to use it, this case?
Of course, it always should be filled with concrete because of this fire.
Always it should be filled.
Yes, always fill it with concrete because otherwise the design principles what we are having for the beam are not as it should be. So you always need to fill it with concrete. But only what I mentioned earlier, this steel member, it's only because of the erection stage when it's still empty. But later on, it always has to be filled with concrete.
Actually, this is good question. And through the design, if somebody did the design through your software, is the software consider the filling section with concrete or no?
Yes, it considers in the composite member in the final stage design.
Okay, very nice, very nice. One question, many questions, I think we will spend a lot of time.
No problem.
One question says, how can safely define the required bearing length for long span delta beam, for example, 20 meter or more, taking in the consideration the rotation in the joint due to beam deformation at the mid-span?
to try to understand the question. So they want to have the bearing length for the beam or for the slabs.
يعني the end of the delta beam, it will be rotated use the length of this beam, 20 meter or more.
No, it will. Our beam design, it depends of the project and of the details, but it can be propped, but only from the ends of the beam. So here you can see, for example, this 18.5.
It is fixed with the column?
Beam. It is fixed with bolts to the wall in this case, but it depends of the project. It can be also propped during the erection for the torsion. And then after you have cast everything in, that there will be no torsion in the beam because we will add those reinforcement bars in the joints of the slabs.
Okay, thank you.
These bars will take the torsion in the final stage.
To
so
prevent the rotation
erection,
of
the torsion is applied.
Okay, understood. The question also regarding the robustness requirement to avoid disproportionate collapse. What are the horizontal ties arrangement between the precast hollow core units at the delta beam? Example, internal floor ties within hollow core unit.
These bars are between the hollow core units. There is always this bar, which will restrain, of course. If you think about the beam and column, then can be bolted dowels through the beam, like in this most case, or can be similar to precast what we have seen here. Sorry, here. So here the bolts are going through the beam, which are working as a shear dowels against the proportionate collapse. Or like here, it can be continuous beam, which is already those dowels are going through the beam, and of course this will take care of that.
Okay. The other question, since we use a slimmer floor system, we will gain a reduction in the overall building weight, thus some saving in foundation size and seismic load mitigation. But in the same time, the overall building system may become more flexible, thus for lateral deformation, which is critical for control lateral serviceability requirement, the glazed facade. The question is, what is the limit where we can say that the slimmer system could change the overall building system behavior?
No, of course we will check it. If the consultant has glass facade or some critical facade, we need to limit our beam deflection, like with any other beam, Elber 500 or Elber 250, depending of the design, whatever is the requirement. So this we have to limit. And like I mentioned, the deflection control during the erection, we are doing pre-campering the beam. This will reduce the deflection in the erection states. So those are the means by. So of course, these stiffness values you always put it in this ETAPS model and then analyze it accordingly. And I think like with any other beam, the same principles will be applied.
Okay, the other question said, how to model the B delta beam in the traditional software, such as a tab? What are the assumptions that need to be modified in the model to consider the actual behavior of the B delta beams and its connections?
It's most cases it is modeled as a steel beam because it's closer to the steel beam, only the infill concrete inside the beam. And then you need to use the generic section, so we need to input values for the generic section in ETAPS. And same applies if you have start prop, for example.
Okay, other question. How to achieve the continuity action as continuous beam in the B delta beams? What are the continuous connection details? Actually, this is the question came from the friends who couldn't be able to attend the seminar, but I think from this picture, it is clearly the continuity of the beam, I think.
Exactly right. So we have this beam going over the column,
and
where
fix with the column.
we create these holes in our beam, which allows these bars going through the beam. So and then it will be cast full, so it is all in one casting there inside the beam, and then you will continue with the upper column on top of it.
Okay.
This is the most common for the continuous.
Clear. I think it is there is a question, two question, I think more for delta beam and continuous beam. I think the shape size, I think this is the same indicative moment. For delta beam, in continuous beam, the shape and size of section will be same at negative moment.
Same section will be there, but locally we can maybe I will show you in our software. You can still see the screen, right?
Yes, clear.
So if it's a continuous beam, we can add locally some let's say top bars or top plates on the section where you have continuity in there. So if you in this case you can see I added 2 additional bars for the section. So we can, if it's required for the negative moment, we can do this kind of changes locally there in the beam section. This will be all done in our factory already, and it is all included when it brings to the site. And here, of course, accordingly, these values for sagging and hogging stiffnesses will increase if you add some bars here on the top.
Okay, I think we have last 2 questions.
Yeah.
If I have hollow core slab and I have a problem in execution of the beam, can we consider that the delta beam, it is the best solution?
Or can you repeat the question?
We have problem, we have hollow core slab. And we have a problem with the time execution. It means the question, what I understand from this.
So they are asking if
reducing the time,
this is a
and
fast
what is the
system
cost?
to erect. Yes, it is very fast actually to erect. They have done projects with a floor cycle of 4 days. I think are the fastest in my knowledge. So every floor in 4 days, 1 floor per 4 days. So it is very fast. It doesn't require much labor on the site. We have one nice reference from Canadian project where they were using I think 5 guys in total on the site, and the floor cycle was 4 days. So it's very fast. And of course, if you save time, you also save money.
Very nice. Last question. I think we have this last question. I will ask you why I have to use delta beam, Mr. Visa.
Because it's effective system. It's a state of the art. It's a flat slab system. It creates you savings on the site. In design, we are giving our support. So I think these are the main benefits what you will gain with our system.
That means, if I understand, because of course there is a problem, we can say faster construction and the economic side and the money solution with the drop beam, we can gain all this benefit. This is
Correct.
What you mean?
Correct. This is the summary of that, yes.
Thank you very much, Mr. Fiza, for this very nice presentation.
Thank you.
We received only one
Yeah.
question also. We said last one, but the engineer asked also, may we have an idea about the cost of the stud drill?
Yes, sure, but
punching?
For the studs also, we would like to have, if somebody could send us the project details so we can do a proposal. We will calculate studs, whatever is required for that project, and then we will quote the same. So you can compare the quotation for the studs and your current system.
Many questions came, all of this question about an idea about the cost of delta beam. Really, it is an important factor in the construction, as you know. The contractor always considering about the cost.
Definitely, yes, and everyone is are taking care of the costs, and this I would reply a bit similar that because it's not like I-beam that you always have the same blade thicknesses or you have the same section. We can modify the section and we can modify the beam according to the project. So we would need the project details, the slab layout to be able to design the beams. Or if you have already ETABS model, we can utilize that. And then we can give, after designing the beams, we can only give you the pricing for the project.
Okay. Also,
so
one
please,
question.
if you are interested, please get in touch with us, and we will give our quotation and the proposal for the beams.
Very nice. So one question is said, can we have more information about the technical instruction for the execution?
Yes, we can, and we have in our each technical manual for the beam and also for the studs. We have this erection installation instructions in the end of the manual.
Okay. Okay. Thank you very much. I think this is the final question. No more question. There is one friend, he raises his hand, then he lower his hand. If anybody has any question? Engineers? That means that is the final question. Mr. Fida, thank you very much for this very nice presentation, and we hope to see you in other seminar, inshallah.
Thank you very much for this opportunity, and yes, keep in touch if you're interested to utilize our solutions with your project.
Thank you. Thank you. Thank you.
Thank
شكرا
you.
لكم جميعا زملائنا. نهاية سيمينارنا اليوم مع مستر فيزا ميتنن التكنيكال مانجر لبيكو في الإمارات العربية والسعودية، وإن شاء الله لقاءنا بالأسبوع القادم بالكونكريت تكنولوجي، مشاكل الخرساني، درجات الحرارة للماس كونكريت، الكونكريت ميكس ديزاين، إن شاء الله بالأسبوع القادم وبتكونوا معنا. السلام عليكم.